Hi dear, last class we have discussed how to arrive at the structure of the organic compounds, right? So what we are supposed to do, first we have to connect all the carbon in a line or in a branched manner or in a ring form, and then we have to satisfy the valencies of the carbon by connecting to hydrogen, right? So this is what we have seen in the last class. So next one is isomerism. Okay, what is meant by isomerism? If two or more organic compounds having the same molecular formula, so same molecular formula but different structural formula, right, are called isomers of each other, and this phenomena is called isomerism. Okay, we'll see. It will have the same molecular formula but the structure will differ. Okay, the molecular structure will differ. Okay, example, pentane. For example, I am doing it for pentane. Okay, pentane. Pent means what? The prefix is pent means 5. That means carbon is 5. Pentane, ane means what is that formula for alkanes? CnH2n plus 2. This is a general formula for this, right? So C5 means H 2 5s are 10 plus 2. So C5H12, right? C5H12 is the formula for pentane. Okay, so first we'll go for the straight line, long chain method. Okay, so how many carbons are there? 5 carbons are there. So connect in a straight line, 1 2 3 4 5. So 5 carbons. So so now the all the 4 carbons balance is here also 4 satisfy, here also 4 satisfy. Now 1 2 3 4 5 is there, again 5 10 plus 2 here, so 12 hydrogens are there. Okay, this is pentane. So next one we can do it in a branched manner. Okay, branched manner. C carbon 1 more will connect here. Okay, satisfy, here also satisfy, here also satisfy, here 1 2 3 4 1 2 3 4 5 6 7 8 9 10 10. How many hydrogens are there? 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so this is your branched one. Carbon valency is also satisfied, 1 2 3 4 here. Okay, and one more structure. This is also branched one. Okay, this carbon valence is satisfied. Here we need to satisfy this 1 2 3. Okay, 1 2 3 1 2 3 here 1 2 3 4. Okay, hydrogen 1 2 3 4 5 6 7 8 9 10 11 12. This is one of the branched structure. of pentane. Okay, so if you look at these all these structures of pentane, this is a straight line and these two are branched things. Okay, these two are branched things, but if you look at the structural arrangement of these elements, they differ. Okay, but the chemical formula is C5H12 only. Okay, so these are the isomers. These are called isomers. That means what? It has the same chemical formula but different structural formula. Okay, different structural formula. Okay, next one is heteroatom. What is meant by heteroatom? Usually in organic compounds we are seeing carbon to hydrogen bonding only, right? Carbon to hydrogen. Other than hydrogen, okay. In hydrocarbon chain, one or more, so many hydrogen atoms are connected to the ends, right? So one or more hydrogen atoms can be replaced by other atoms. Not hydrogen, replaced by other atoms in accordance with their valency. Okay, to satisfy its valency. Okay, these elements that has replaced hydrogen is known as heteroatom. Okay, the elements that replace for example, if chlorine valency is 1, right? So in place of one of the hydrogen atom, if you put chlorine, then that chlorine is called heteroatom. Okay, like that. In hydrocarbon chain, one or more hydrogen atoms can be replaced by other atoms in accordance with their valencies. These elements replace hydrogen. The elements that replaces hydrogen atom is known as heteroatom. Okay. These heteroatoms and the group containing these confer specific property to the compound. Okay. If heteroatoms combine with this in the hydrocarbon chain, it will form a it will create some specific chemical property to that compound. Okay, so regardless of the length and the nature of the carbon chain, whether it is a straight or branched or ring, or it is very long or short, but based on the attachment, based on the what are the elements which are attached, heteroatoms are attached, right? So it creates some a specific property to that compound. Okay, that's why it is called a functional group. Okay, these heteroatoms and the group containing these confer specific properties to the compound regardless of the length and nature of the carbon chain, and hence is called functional group. Okay, for example, this heteroatom is chlorine or bromine. Then we'll call group this as halogen family. We'll call these things are halogen family. So we will put halo. Okay, that means chlorine means chloro, bromine means bromo, like that. Okay, the functional group is ClBr. Okay, in case oxygen is attached to it. Okay, we'll classify in 4 forms, that is alcohol, aldehyde, ketone and carboxylic acid. Only we are going to replace one of the hydrogen with the oxygen. Okay, based on the bondings and the attachment with the hydrogen and carbon, this is named as alcohol. That means the functional group will be OH. Okay, what is the formula if the bond present with the hydrogen the OH is present in the chemical structure, then we will call it as alcohol family. Okay, so CHO bond, this bond, and a C double bond with the oxygen, then we will call it as aldehyde. Okay, in this group, if you found this group in the structure, then it is called ketone family. Okay, and this COOH, we'll call it as usually carboxylic acid. Okay, so these are the formulas of the functional group. OH means alcohol, CHO bond, this is aldehyde, CO, this is ketone, double bond with the oxygen, carboxylic acid, COHO. Okay. Next, we have formed some functional groups, right? That can be written in the same pattern. So many elements can be formed, but it has a similar pattern. Okay, similar pattern as well as similar chemical properties. Okay, so homologous series, the series of organic compounds having the same functional group. Same, for example, you are having OH means, that means alcohol family. Okay, alcohol functional group. Okay, it has similar chemical properties are called homologous series. Okay, a series of organic compounds having the same functional group and similar chemical properties are called homologous series. For example, this is methanol, ethanol, propanol. So OH family, OH, this is a functional group, OH is attached to it. Okay, this is actually, what is this methane, CH4. Here one, in place of one nitrogen atom, a functional group is attached, OH. Okay, so all these things will have a same chemical properties of alcohol, right? Similar chemical properties. Okay, and each member differs by successive member by each members differs from their successive members by CH2 group. Okay, so what is the difference between these two things? Okay, this is methanol, this is ethanol. Okay, here extra 1C is there, here extra 2H is there, so it differs by 2 CH2. Okay, if you take the difference of these two chemical formula, you will get CH2. Okay, each members differs from successive members by CH2 group. Okay, for this homologous series, that means they are having the same functional group, and they differs by all these things, methanol, propanol, ethanol, propanol. So all this homologous series will differ by CH2 group. Okay, for example, methane, this is ethane. Okay, so what is the difference? Extra 1C is there and here extra 2 hydrogen is there, so it differ by CH2. Likewise from ethane and propane. Okay, here also extra 1C is there, here also extra 2H is there, so differ by CH2. Likewise for propane and butane, successive, we have to take only not this methane or butane. Okay, you have to take the successive members. Okay, methane, ethane, propane, butane. For the successive, it differs by CH2. Okay, so by the formula, it is differed by CH2. So how much, what is the difference in molecular weight of these successive members is 14 units. Okay, the molecular weights of these two sets differ by 14 units. How? The atomic mass of it differ by CH2, right? The atomic mass of carbon is 12 unit. For hydrogen, it is 1 unit. Okay, 2 hydrogens are there, so 1 more units. Okay, so totally 12, 13, 14. So the difference in molecular weight will be 14 units. What is the difference in molecular weight of the successive members? Okay, successive, next consecutive members, it is differ by 14 units. This is based on the molecular weight. Okay, next. So these homologous series, that means compounds having the same functional group will have some characteristics. Okay, all the members of the series can be represented by the same general formula, right? Same general formula. That means alkane A in a single bond means we can represent it by CnH2n plus 2. Already we have seen this general formula, right? Alkene double bond means CnH2n. Alkyne means CnH2n minus 2. Okay, and all the compounds of the series show similar chemical properties. It shows similar chemical properties. Okay, and also there is a regular graduation in a physical property. Regular graduation, because each member will be differ by CH2, right? That means if the chain is increased, the carbon to hydrogen bond chain is increased, the molecular weight will also increase, right? When it is increasing, because we are going to increase, we are going to put n instead of n 1 2 3 and all. Okay, it's keep on increasing. While it is increasing, its molecular weight will also increasing. Because of that, there is a gradual there is a regular graduation in the physical property, increase in the changes in the physical properties. That is, while means the melting and boiling point increases with increasing molecular mass. If the molecular mass is, if the more carbon is present, more hydrogen is present, then molecular mass will increase, and it increases the melting and boiling point of that particular compound. Okay, like with solubility in a particular solvent. Solubility in a particular solvent increases with increasing molecular mass. Okay, so that's why there is a change, a regular change in the physical properties of the homologous series. Okay, but it shows similar the chemical property will be similar, but the physical property will change, because see, it is easy to break this bond, right? Right, this is a simple bonding, so we can easily break this by simple heating, right? So if it is a long chain like this, it takes some time. Okay, it needs more heat, right? So the melting and boiling point will increase like that. Okay, so these are some of the characteristics of homologous series. It has a general formula and it has similar chemical properties, but there is a change in the physical properties based on the increase in the molecular mass. Okay, next, how to name these carbon compounds. Okay, so you know that we have to name, they can give the name to any assigning name to any compound based on the IUPAC, right? International Union for Pure and Applied Chemistry, right? IUPAC. Based on this only we'll be naming the compound, right? So how to name this carbon compounds? First, identify the number of carbon atoms in a compound. Okay, how many carbon atoms are there in a compound? Okay, the compound having usually we will have a, if a compound is having one carbon means we'll call it as meth. 2 carbon atom means eth. 3 carbon atoms prop. 4 carbon atoms bute. 5 carbon atoms pent. 6 carbon atom hex. 7 carbon atom hept. 8 carbon atoms means oct. 9 carbon atom means non. 10 carbon atom means decad. Okay, how we used to name the quadrilaterals, right? Sorry, polygon. If it is a 3-sided mean triangle, 4-sided mean quadrilateral, 5 means pentagon, 6 means hexagon, likewise. So there is a specific name for that, that is prefix. Usually based on the number of carbon atoms will give the name. If the carbon atoms, number of carbon atom present is 5 means, then we will start with the pent. Okay, if it is single bond, we will complete it by giving the name ANE, methane, ethane, propane, butane, pentane, hexane. Okay, heptane, octane, nonane, decane. Okay, if it is a double bond means we will replace this ANE by ENE. Do you remember this? Alkene, ENE. Not methane will not come. Methane is only methane. The ENE family, alkane double bond family, will start with the ethane, ENE, likewise. Okay, so first we have to identify the carbon atoms, and we have to give the prefix like this. Standard prefix are there. Okay, in case a functional group is given, it is indicated either by prefix or suffix. If the functional group is present means we can either connect with this carbon atoms either at the suffix means at the end or in the prefix. Okay, so how will you add this means, you just now we have seen alkene double bond means we have to add it in the suffix in the end with the ENE, right? Alkyne, triple, this is double bond, this is triple bond, right? Alkyne means YNE, we have to replace, add YNE. Okay, alcohol family means OH. Okay, aldehyde means Al, ketone means ONE, carboxylic acid means methanoic acid, ethanoic acid, like that. Okay, chlorine and bromine, these things alone we will connect in the functional group will be connected as a prefix. Okay, bromo propane, okay, chloropropane, like this. Okay, this only the exception is this halogen family will be connected as a prefix. This is the only difference. Okay, and the last thing is to modify the name of the carbon chain. So we said we are going to add the functional group to it. Okay, functional group, we are going to add, for example, alcohol means we are going to add sorry OL, sorry, OL, we are going to add OL, right? Oh, okay, we are going to add OL if the alcohol is if the function is alcohol, right? We are going to name that. Okay, methane, for example, to modify the carbon chain, if we are going to add a functional group, that functional group that starts with this vowels A, E, I, O, U, then how you have to add with this one means you have to replace this E. You have to replace this E. That means E, we have to take out this E and add this OL. Okay, this is methane general. We are going to replace one hydrogen with this functional group OH. Okay, it becomes methanol. Okay, OH represents the alcohol group. Methanol means OL we are going to add, right? How will you add this? Not methane all, not like that. Okay, when because this functional group starts with the vowel sound means vowels letter means, then we have to remove this E and you have to add this OL. Okay, remove this E, take it from there and add OL, methanol, ethanol, like that. Okay, so see from the book, textbook, haloalkane, only the halogen family will be added as a prefix. Okay, this functional group as prefix as chloro, bromo, right? This is chloropropane. Okay, propane means 3 carbon atoms. Okay, attached to that one of the hydrogen is replaced by this heteroatom, that is chlorine, right? So how will you call this? Chloro. Okay, so chloropropane. Likewise here it is replaced by bromine, so it is bromopropane. This is the only thing attached as a prefix. Okay, the remaining things will be attached as a suffix only. Okay, alcohol family means OL we have to add, right? Instead of one hydrogen, we are replacing this one hydrogen with this OH family. OH family means what? Alcohol family, propanol. Okay, propane, you have to remove the E and you have to add OL. Aldehyde means Al. Okay, so aldehyde means you got this functional group. What is the symbol for formula for this aldehyde? CHO group, right? So you got this CHO group. Okay, ketone, what is the formula? You have CO bond, right? Ketone. Here you can see this ketone group. Okay, CO bond. Okay, with the double bond. Okay, this is propanol. ONE, it starts with the vowel, so we have to remove the E and we have to add the ONE. Okay, carboxylic acid. What is this? COH and double bond with O. This is the formula, right? So this means this shows this is the acid, carboxylic acid. So 3 carbon is there means this is propanoic acid. Okay, alkene means ENE, you know. Alkynes means YNE, you know. Triple bond, double bond, right? So this is how you have to name the carbon compounds. Okay, thank you.